Today we are in section 3.3, solving equations with variables on both sides. All right, so this is just another way that we're going to explore this whole solving equations. We still use inverse operations. Our goal is still to get x by itself on one side of the equation. It's just now we have an x or a variable on both sides of the equation. So let's see what it looks like. Go ahead and write this equation down on your notes. 7n minus 5 equals 10n plus 13. Okay, so 7n minus 5 equals 10n plus 13. The difference here is now we see an n on both sides of the equation. So I need to decide, am I going to subtract 7n from both sides, or am I going to subtract 10n from both sides and move the 10n over to the other side? And here's how I know what to do. I need to look at each one of these variables and decide which one is the basically the lesser value of the two. Which one is the lesser value? 7n. So that's the one that I'm going to subtract and move to the other side. Okay? And I subtract it because 7n is positive here, and I want to move the whole term to the other side. And the reason I choose the lesser value is because I want to have a positive coefficient attached to my variable. Does that make sense? So if I had subtracted 10 from 7, it would have been negative 3, which isn't a huge deal with equations, but when I get into some of the other concepts like inequalities, I want to try to avoid having a negative coefficient. So why not just start practicing that now? All right, so that's why we move the smaller or the lesser of the two values. All right, now what's left on the left side of the equation? What am I going to bring down? Negative 5 equals 3n plus 13. Now this is my standard two-step equation that you've been solving for several days now. So now I have 3n plus 13 on the right side, and I have to get n by itself. My rule says that I move the number that's by itself first to the other side. I need to subtract 13. Why did I subtract 13 instead of add? Yeah, I have to do the opposite. 13's positive. So now my 13's cancel. I'm one step closer to having n by itself. Now I have negative 18 equals 3n. Well, how would I solve for n? Divide both sides by 3. And n equals negative 6. All right, your homework tonight is going to ask you to check. You're going to check by taking negative 6 and plugging it back into the original equation. So 7 times negative 6 minus 5 equals 10 times negative 6 plus 13. All right, and now we're going to use our calculators, and we're going to plug in these numbers. 7 times negative 6, 7 times negative 6 is negative 42. Minus 5 would give me what? Negative 47. So now I need to test the other side. What's 10 times negative 6 plus 13? Negative 60 plus 13 is also negative 47. So it checks out. Both sides check out. All right, you see how I can check? So if that is the correct solution, both sides will equal each other. All right, so let's look at the second one now. Look at the second equation. The first thing I need to recognize is where are my terms with the variable? Negative 8b and 4b. Well, I know that I can only have a variable on one side of the equation, so I have to either move the negative 8b or move the 4b. Which one would I move? Why negative 8b?
Because
Because it's the lowest value, right? It's way lower than 4. Okay, negative 8 is way less than 4. So I need to move negative 8b. Well, how do I move it? I would add 8b. Very good. I add 8b to both sides. Add 8b. All right, and I get 12 equals 12b minus 24. All right, go ahead and take a few minutes to finish solving. Okay, so what do I do next? Add 24 to both sides. And I get 36 equals 12b. Now what do I do? Both sides, and b equals 3. All right, and again, I need to check. I'm not going to check on all of them today during class, but just remember you need to check them on your homework tonight. If I were to check this, I would say negative 8 times 3 plus 12. I just plug it back into the original. Equals 4 times 3 minus 24. All right, and both sides need to equal each other. So when I simplify it, negative 24 plus 12 is negative 12. And 12 minus 24 is also negative 12. Checks out, and we're good to go. Our answer is B equals 3. All right, so if you take a step back and just look at the whole screen, that's a lot, isn't it? That's a lot more than our 2x equals 10 and x equals 5, right, that we started with a week ago. So these equations have grown, but if you look at each individual step, is any individual step difficult? No, it's not. It's just step by step. We just have to remember to take it one step at a time. All right, any questions on this? Choose the lesser value of the two to move. All right, that's just the extra step that we're adding today. Let's look at example 2. It says the Spanish club is arranging a trip to a Mexican restaurant. Those who go must share the $60 cost of the bus. The buffet is $5 per person. How many students need to sign up in order for the trip to cost $10 per person? That should say person. All right, so every equation needs a what? Equal sign. All right, so we start there. And then we also look for the total. Well, in this case, does it give me the value amount of the total? Does it tell me how much the total is? It doesn't. But I know I need my trip to cost how much? $10 per student or per person. So I know that the total needs to be $10 per person. Does that make sense? And the expenses that make up the total would be, how much is the bus? $60 for the bus plus how much per person? So here's what we need to look at. $10 per person, is that the same person that I'm talking about that's $5 per person for the buffet? Yeah, it's the same person. So that's why it's the same variable. And we also saw this in our example yesterday in the word problem with the pom-poms and the noisemakers. Y'all remember that? Because I was buying the same number of both, it was the same variable. Well, in this case, the bus trip plus the buffet cost per person makes up the total. It's the same person that we're talking about. It's the same variable. All right, so that's why the P is on both sides here. Well, I just solved this like a regular, equation now at this point. But again, I have variables on both sides, so which one am I going to move? The 5P. How do I move it? Add or subtract? Subtract 5P from both sides. And now 60 equals 5P. Now what would I do? Divide 5 by both sides. And how many people can go? 12 people. So here's what it's saying. If 12 people go, then the cost will be $10 per person. All right, and again, if I plug 12 in for P here and in for P here, it'll work out to be equal to each other. Okay, so that's my answer, 12 people. Example 3. We have equations sometimes that will apply, basically, they'll go by different rules, all right? So we call them exceptions, or exception would probably be a good word. So this isn't your typical equation, all right? There's something that's different about this type of equation. Well, first of all, I see some distributive property here. So I want you to distribute 5 times 2x plus 1, and then rewrite the equation. Go ahead and distribute it. When I distribute 5 times 2x, I get 10x plus 5 equals 10x. Well, I know that I can't have variables on both sides of the equation. But what do you see that's different about this one? They're the same variable. So when I try to move one or the other, what's going to happen? They're going to cancel out. They're going to completely cancel out. All right? And what do you have that's left?
5.
You have 5 equals 10x minus 10x is 0. Well, does 5 equal 0? No. So it's actually going to be no solution. There is no solution here. All right? And your tip here is if your variables cancel out, your solution will be no solution. It's not 0. Your solution is not 0. That's an answer. You cannot find an answer. It is not possible to solve this equation. There is no solution. If the variables cancel and they leave an unequal amount that's left, there cannot be a solution. All right, so same thing goes with the second one. Go ahead and do your distributive property to solve. All right, so 3 times 5x is 15x minus 15 equals 15x. So again, the first thing I notice is I have variables on both sides, but what do I also notice about my variable values? They're the same. So when I try to subtract them, they're going to cancel out. And negative 15 does not equal 0. Because those values don't equal, my answer is no solution. No solution. All right, so equations with no solutions will have variables that cancel, and they'll leave other values that don't equal 0. All right, so equations with no solutions. So now go ahead and do your distributive property for both of these equations. Go ahead and do your distributive property both for 6x plus 2 equation and 4x plus 6 equation. Okay, so 6x plus 2, what did you get when you did distributive? Equals 6x plus 2. Okay, so now not only are our variables the same, but the entire expression on both sides of the equal sign is exactly the same, right? So here's what happens. Let's say we had an x value of 5. We plugged in an x value of 5 here. What's 6 times 5?
30.
What's 30 plus 2?
32.
So guess what's going to happen when you plug it in on the other side? It's going to equal 32. It doesn't matter what x value you plug in, both sides are going to equal. So because of that, all numbers are solutions. All numbers, any number. All numbers are solutions. All right, same thing goes with the second one. 4x plus 6 equals 4x plus 6. Same exact expression on both sides, all numbers will be solutions. Do you see the difference between examples 3 and 4 though? In example 3, only the variable was the same. Because it left numbers left over that did not equal, there's no solution. But in example 4, both sides of the equation are exactly the same, so any number could be a solution. There is not one specific number. And guys, I'm going to say it again. This is very rare and few and far between. This very rarely would happen. But you may see one, you will see one on your homework. You may see at least one of this type of problem on your quiz or test, one or the other. So just be mindful. If you see the exact same expression on both sides, all numbers are solutions. Now, in example 5, we're translating a verbal sentence into an equation. So we got to look for our key words. Let's read the equation together. It says, or I'm sorry, the sentence together. It says 9 plus 2 times a number is equal to less than 3 times a number. All right, so we just need to start breaking it down into its parts. The very first thing we start with is our equal sign. We find the key words in the phrase that tell us where the equal sign goes in the sentence. You see that? And write your equal sign on your paper. That just divided your sentence into 2 parts. Everything before the words equal to goes on the left side, and everything after goes on the right side of the equal sign. So now, how could I write 9 plus 2 times a number? 9 plus 2 times a number, Amy? 9 plus 2x. Does anybody remember, and it's been a while since we talked about this, what happens with the word less than and fewer than? The word than, what happens with that, Julia? You switch the order. So now instead of it being 2 minus 3n or 3x, it's going to be 3x minus 2. All right? And that's only because you see the word less than. I'm taking it from that number. All right? So 3x minus 2. And now you can solve. Go ahead and solve this. We move the 2x to the other side because it's the smaller one. And then we get 9 equals x minus 2. So then we add 2 to both sides, and we get 11. All right, who got 11? Who got 11? Did you get 11? Well, yeah, but 1x is the same thing as x.
I got 11. Oh, yeah.
Right, because 1 is understood.
Okay.
So, but yeah, if you put 1x, that's totally fine. All right, now try to do the second one all on your own. Okay, so 4 minus 7x equals 12 minus 3x. Which one did you move? Negative 7x or negative 3x?
Negative 7x.
Very good. Did you add it? Yeah. Okay, so if we're moving 7x to the right side, we need to subtract 12 over to the other side. So we get negative 8 equals 4x. Divide both sides by 4, and x equals negative 2. All right, who got negative 2?
I did that.
Get negative 2?
I did it the other way. Yeah.
Okay, all right, last example. The perimeter of a square. Well, I know a couple things about a square. I need you to write down the figure and write down the formula. Okay, the formula for perimeter of a square, does anybody remember? 4s. 4 times the side length. Why? Because what do I know about the sides of a square? They're all equal. If 1 is 5, they're all 5 inches or whatever. Okay? So all the sides of a square are equal. All right? Go ahead and draw the square and the dimensions and then the formula. We'll go over it. All right, so if all the sides of the square are equal, that means that 7x plus 30, once I know what x is, will be the same number as 12x. The side lengths are equal, so I can set them equal to each other. 7x plus 30 equals 12x. We've already established each side of the square is equal to the other, so that means that 7x plus 30 is equal to 12x. And if that's true, then I can solve for x. I just set up an equation and I can solve for x. Go ahead and solve for x. All right, so subtract 7x from both sides. 30 equals 5x. Divide both sides by 5, and x equals 6. Did everybody get 6? Okay, but that's not my answer. If x equals 6, I can plug it back in either to this expression or to this expression to find the side value. So if x equals 6, what would my side value be?
It would be 72.
What's 12 times 6? 72. What is 7 times 6 here?
42.
42 plus 30? 72, you see? Okay? So what I'm going to do now that I know one of the side lengths, now I can take that number and I can find the perimeter. Does that make sense? So I did all the work initially, setting the sides equal to each other to figure out what x was so I could figure out what is the side length. Now that I know it, I can go P equals 4 times 72, which is my side length. And now what's my side length?
280. Wait.
Units.
What's the measurement?
288 units. Okay? Not too bad? All right, if you understand that, that's everything you need to know for section, what are we in, 3.3? Okay, that's it.